Listen children, here you can see two beakers. One contains aqueous NaCl solution and other contains aqueous sugar solution. How will you identify which beaker contains sugar solution and which contains the NaCl solution? Obviously, the beaker indicated by the glowing bulb contains the salt solution and other beaker where the bulb is not glowing contains the sugar solution. Substances like NaCl which conduct electricity in their aqueous solutions are called electrolytes, and molecular compounds like sugar which do not conduct electricity are known as non-electrolytes. This classification of substances into electrolytes and non-electrolytes based on their ability to conduct electricity was made by English chemist and physicist Michael Faraday. He further classified electrolytes into strong electrolytes and weak electrolytes. According to him, strong electrolytes dissociate into its ions completely when dissolved in water, while weak electrolytes undergo dissociation only to a limited extent. For example, HCl is considered as a strong electrolyte as it undergo dissociation completely when dissolved in water. The aqueous solution of HCl contains H plus and Cl minus ions. On the other hand, acetic acid is considered as a weak electrolyte as it undergo dissociation to a very limited extent in water. An aqueous solution of acetic acid mainly contains unionized acetic acid molecule in equilibrium with the some H plus and acetate ion. Hence, the equilibrium involving the ions and its unionized molecule in an aqueous solution of weak electrolyte is called ionic equilibrium. Next, acids, bases and salts. Acids, bases and salts are commonly used in our daily life. For example, orange juice and lemon juice contain citric acid and ascorbic acid. Tamarind contains tartaric acid. Curd contains lactic acid. Spinach contains oxalic acid. Salad flavored with vinegar contains acetic acid. It is amazing that HCl is produced in our body and helps in digestion. Bases used in our daily life include ammonium hydroxide in cleaning liquids, magnesium hydroxides as antacid, and sodium hydroxide in the manufacturing of soap. Many compounds known to us may be classified as salts. The salt most familiar to all of us is sodium chloride, which form an important component in our diet. Washing soda used for washing and baking soda which is used in baking of food items. These are another commonly used salts. The word acid is derived from Latin word acidus which means sour. Acids exhibit certain properties in their aqueous solution. They are sour to taste. It turns blue litmus to red. They react with active metals such as zinc and liberate hydrogen gas. On the other hand, bases have the following properties in aqueous solution. They are bitter in taste. They turn red litmus to blue. They are soapy to touch. Arrhenius gave the first real classification of the chemical nature of acids and bases, which is popularly known as Arrhenius theory of acids and bases. According to this theory, acids are substances which produce H plus ions in water. For example, HCl contains hydrogen and ionizes in water as H plus and Cl minus ions. The ionization of HCl is shown like the equation 1 or 2. The H plus is very reactive and cannot exist independently in aqueous solution. Instead, it binds the oxygen atom in water molecule to form H3O plus hydronium ion. Next, bases are substances which contain OH minus ions and ionizes in aqueous solution to give hydroxide ion. For example, NaOH, sodium hydroxide, contain an OH group and ionizes in water as Na plus and OH minus ions. The ionization can be represented in the form of equation as shown here. Next, limitations of Arrhenius theory. It is limited to aqueous solution only. For example, HCl is considered as an acid only when it is dissolved in water, not in some other solvents such as benzene. Next limitation, some substances exhibit the properties of bases though they do not contain hydroxide ion. For example, liquid ammonia behave as a base although it has not contain any hydroxyl group in it. In an attempt to overcome the limitations of Arrhenius theory, Danish chemist J.N. Bronsted and English chemist T.M. Lowry proposed more general definition for acids and bases. According to the Bronsted-Lowry theory, acids are substances that are capable of donating a hydrogen ion or proton, and bases are substances which are capable of accepting a hydrogen ion or proton. For example, consider the ionization of hydrochloric acid in water. HCl plus H2O reversibly gives H3O plus Cl minus. In this example, HCl donate one proton to become Cl minus ion and H2O accept one proton to become H3O plus ion. Thus, HCl is an acid and H2O act as base. Here, H3O plus is known as conjugate acid because it accepts H plus ion, and Cl minus ion is known as conjugate base because it loses its H plus ion. Consider another example. NH3 plus H2O reversibly gives NH4 plus OH minus ions. Here, H2O give one H plus ion to NH3 because H2O ionizes as H plus and OH minus ions. So, this H plus ion is given to NH3. So, H2O acts as acid and NH3 accept that H plus ion. So, it acts as a base. And on product side, NH4 plus is formed by accepting a proton, so it is known as conjugate acid, and OH minus is formed by losing a proton, H plus ion, so it is known as a conjugate base. Next, limitations of Bronsted-Lowry theory. This theory fails to explain some reactions that do not involve a proton transfer. Next one, it fails to explain the acidic behavior of the electron deficient molecules like aluminum chloride and boron trichloride, AlCl3 and BCl3. So, in 1923, G.N. Lewis proposed the more general theory of acids and bases. According to this theory, acids are species which accept electron pair and bases are species which donate electron pair. Example for Lewis acids are H plus ion aluminum chloride, etc. And example for Lewis bases are ammonia, water molecule, etc. Limitations of Lewis theory. This theory fails to explain the strength of acids and bases. All the acid-base reactions do not involve coordinate covalent bond formation. So these are the important limitations of Lewis theory.